Congruent. All right, ready. Welcome, ladies and gentlemen. We are on our last lesson for topic 9 before we move into topic 10, 9.5. We are looking at making connections between transformations and shapes that are congruent. So we're going to be using our rules and we're going to be using different transformations to kind of figure out how do I get from one congruent shape to the other. So first, we're going to write down a key vocabulary word that you need to know, which is congruent. We've talked about this before, but you need to understand that congruent means the shape is the same size and the same shape. Okay, so if I'm trying to decide if two shapes are congruent, I'm looking to make sure that they're the same size and the same shape. All of the transformations that we've done already are do keep congruency. So translations or slides, rotations or turns, and reflections or flips. They all keep congruency. We don't change size, we don't change shape, we're just moving the shape around, okay? And so what we're going to do is we're going to start combining these transformations together. We've done a little bit of this, but we're going to combine them together and then talk about how we know that the original shape and the new shape are congruent, okay? So the first thing we're going to do is apply the transformation in the series. Each transformation is going to be applied to the image of the previous transformation. So I will reflect this across the x-axis, and then the new shape, I will then do this transformation here of x minus 3y. And then that new shape, I'll then reflect across the y-axis. So we're just going to have a series of repeated images all across my coordinate plane. We're going to label each image with the letter of the transformation to keep track, and then we're going to compare them. Okay, so I'm going to do this with color coordination. I'm also going to do this using my X and Y coordinates and my rules because I really want to connect those two things together. So if I make this 1, 2, and 3, the point for 1, we're going to write these down. Okay, so I got my X and Y coordinates here. So that's just by looking at the point on the shape and looking at where it is for X and Y. We're starting with our initial image, which is at X, Y. And then we're going to do some transformations to them and see what's going to happen. Okay. So the first one that we're going to do is to reflect across the x-axis. So remember that our x-axis is here, and I'm going to do a reflection. The rule that I'm going to use for reflections is x negative y. When I reflect across x, I change the sign. I change it to the opposite sign for the y term. So I'm going to look at all of these, and in all of these, I'm going to take my y and I'm going to change its sign. So all of these happen to be positive, so I'm going to turn them to their opposites, which is negative. So my new point will be 3, 4, negative 4. 5, negative 4, and 5, negative 2. Now, when I go to graph these points, I can graph my points that I have here, or I can just count and reflect that way as well. They should match. It should be the same thing, okay? So I should be doing here 3, negative 4, 5, negative 4, and 5, negative 2. This is now shape A. Okay, we just did step A. So now we're going to do step B. Now step B says that my original coordinates, which in this case are going to be my A coordinates, so my blue ones over here, are going to be transformed into x minus 3. So because I'm dealing with my x-axis, I'm going to be going to the left, okay, negatively. And I'm going to do that by 3. So basically for all of these points over here, all the x's I'm going to subtract 3 from, okay, and I'm going to do them down here. So 3 take away 3 is 0. So my new point for point 1 is 0, 4, negative 4. 5 take away 3 is 2, negative 4. And 5 take away 3 is 2, negative 2. So I just subtracted 3 from each x and rewrote my points down here. Now, when I go to graph them, again, I can graph these points, or I can count 3 to the left. So 1, 2, 3, 1, 2, 3, 1, 2, 3. Every time I draw my new shape, I want to double check that it is the same size and shape as my original image. Every time I make these rotate, because we're rotating, translating, and reflecting, translating, and rotating, they should always be the same size and same shape. If I get a weird size or shape, then I know I probably did something wrong. Okay, so that was B. Done. So now I'm going to take my B shape and I'm going to reflect that across the y-axis. So now I'm going to be reflecting over this line. Okay, my rule for reflecting over the y-axis is to do the opposite letter and change x. So my x's over here, these are all going to change to their opposite signs. So 0, the opposite of 0 is just 0. It doesn't have an opposite, so that stays the same. The opposite of 2 is negative 2. And the opposite of 2 is negative 2. So again, I can plot these points, or I can count how far away they are and plot them down here. So my 1 point's going to stay here, negative 2, negative 4, negative 2, negative 2. This is my new reflected image of C. And now I'm going to move on. So now we're going to apply this translation. This is a slide, but not to X. So I'm not going right or left. I'm going to apply it to Y, which means I'm going up or down. Adding 4 means I'm going to take this C and I'm going to move it up 4 places. Or, in other words, I'm going to add 4 to my Y. So all of these y values over here are going to get plus 4. So when I go to rewrite my coordinates, I'm going to do negative 4 plus 4 is 0. Negative 4 plus 4 is 0. Negative 2 plus 4 is 2. So my new points from C to reflecting over, to translating 4 up will be 0, 0, negative 2, 0, negative 2, 2. 0, 0, negative 2, 0, negative 2, 2. So this is my new shape, which is the letter D. So this last step is to rotate 90 degrees clockwise about the origin. And I would use my little handy table or my notes or my memorization that 90 degrees clockwise means that I'm going from here to here or to the right. And I am flip-flopping X and Y. And my original X value will be negative. Okay, so as we go to write these over here, I'm going to flip-flop X and Y, the location of where they are, move them. My X becomes my Y, and my Y becomes my X. So 0 and 0 flip-flopping is still 0, 0. And the original X, whatever was here, changes signs. Okay, so these numbers are going to change signs. If they're negative, they turn positive. If they're positive, they turn negative. Now, what's special about 0 is it can't change signs. So 0, 0 is going to stay 0, 0. But when I rearrange 0 and negative 2, my negative 2 is going to change positive. 2, negative 2, my negative 2 is going to change positive. So those are my new points. So when I go to graph them, I have 0, 0, 2, 2, 0, 2. There is my shape. This is letter D rotated 90 degrees clockwise. And now I have done all of the translations I need to do. So what we're going to do now is talk about, we're comparing how does that size and shape of this original image compare with our final image here. Well, I know that it is a right triangle and E is a right triangle. I know that the legs of the right triangle are 2 by 2 and the legs of E are 2 by 2. So therefore I can confirm that they are congruent. They are the same size and same shape. Okay, this next question is having us do the opposite. Instead of us following a set of sequences, we have to come up with a set of sequences of transformations that's going to transform figure A into figure B. So I need to get the blue figure to look and be in the same position as the green figure. So just by looking at them, you can probably tell that they need to be reflected or flipped. That would probably be the first thing I would do. There are multiple ways to do this though. So just because I tell you a way doesn't mean that there's not another way that you could get figure A to be transformed into the same shape and place as figure B. But the first thing that comes to my mind is that they are backwards. They are flipped. So I would probably say that the first thing I need to do is reflect this figure over which axis? So am I going to flip it over X down here? Or am I going to flip it over Y? And hopefully you said Y because that's correct. So I'm going to reflect this figure over the Y axis. It's the first thing I'm going to do. And I'm actually going to physically do that so that I can see where that puts my shape. Because some of you might think just by looking at it, oh, if I flip it over, we're all good. But let's see if that happens. Okay, so I'm going to go ahead and reflect. So this is 1 away. So there's that. This is 2 away. So here's my next point. 1, 2, 3. 1, 2, 3, 4, 4. Yep. And then this one's 4 as well, but way up here. So my new shape, if I, just reflect it, is going to get me here. But now as you can see, my new reflected shape still is not on top of my old shape. So I need to do something else. So what is a transformation that will push my shape to the left 1 spot? Hopefully you said translate, because now we are going to translate 1 unit left. Or if you wanted to, you could have used your rules and said that we're going to do this and then this. Both of these are correct. They're just 2 different ways to do it. If I slide my shape backwards, I am going to end up right back where I need to be. And that is how I would translate the shape. Okay. On this one, we're doing the same thing. We're trying to get figure B to translate onto or transform onto figure C into the same spot. And again, we're going to have to figure out how to do that. Again, one of the biggest things that I see, and again, there's more than one way to do this, but the biggest thing I see is that obviously B needs to be rotated. Flipping it upside down isn't going to help, but if I rotate it around the center, the origin, that will definitely get it into the same orientation as C. So I am going to say I need to rotate left, and I need to figure out how much. So if I'm rotating to the left, I'm going just 1 quadrant. And when it's just 1 quadrant, that's 90 degrees. And left is counterclockwise. So I need to rotate left or counterclockwise 90 degrees. And so let's perform that rotation and then see where we are. So we can see when we rotate that our shape is not where we need it to be. So now I can count and see what my next move needs to be. So by doing some counting, I can see I need to go up 2 and right 1. So I put it into our algebraic representation here. And if I go my points up 2 and over 1, I'm going to end up right where I want to be. Now on this question, it's basically asking if I have 2 points that are both rotated 90 degrees and then translated down 6, what's the length of the line? Well, it's going to be whatever it was before, because when I translate and move these, they're going to stay congruent. So if they were 3 units before they moved, they're still going to be 3 units away.